So the crankshaft is in. I put the caps on them a bit for now. Now I'm going to put the block on the table, continue and tighten everything up for good. We check the timing marks, we see that they line up, everything is good. I also want to show that there's a number 3C899 on the block, and each cap is marked 1, 2, 3, 4, 5 and so on. Each cap is marked such as 1C899, 2C899 or 3C899. So each cap is numbered in order with the block, and the number matches the block. It's very convenient. You don't need to mark anything. You know there are already factory marks. You take it off, put it back on confidently, and you won't mix it up with other caps. Someone might also notice that the shaft is this blue color and start saying that it's over-hardened and so on. No, it's not over-hardened. I mean, right here, this is where it was heat. He treated these spots, and these spots, that's it. A chemical reaction likely occurred from the oil or washing. Let's say the shaft fits perfectly, it turns easily. You can feel that it's covered in oil from all sides. Everything is great. Just as it should be, it moves smoothly, nothing is in its way, so everything is perfect. And we see there's some axial play, some longitudinal backlash. Well, now we'll fully tighten the main caps and check everything again. So the crankshaft is fully tightened and the torque specs will appear on the screen now. I tightened it the same way, marked it, then turned it 90 degrees until the marks lined up. This is how it turns now. Meaning together with the camshaft, everything turns easily and smoothly. Alright, longitudinal movement. Such longitudinal movement. We take a 0.15 gauge and insert it. We see that the longitudinal movement disappears. That's it. So the crankshaft is fully installed. Everything is great, both shafts are fully installed. Next, I need to install the pistons, but I don't have the piston rings yet, so I need to get them first. Well, for now, I'll clean all the grooves and the combustion chamber from carbon deposits, blow everything out, and prepare the pistons, but I still don't have the piston rings. So, since I don't have the piston rings yet, I'll install the flywheel housing, the front cover, and maybe the flywheel. So, in general, I'll do something so that the work doesn't stop. Next, I plan to install the rear cover, flywheel housing, and front cover. And here is the cover that closes the compressor gear drive. I washed and cleaned all the covers, prepared the bolts and gaskets, replaced and installed new oil seals, purling without a spring. I take the sealant, apply it, put on the sealant, install the gasket, and install the covers. Done. I applied the sealant, pull the gasket, that's it. Now let's check the timing marks again, and we can install the cover. As for these covers, I also applied the sealant, installed the gasket, and tightened it. And here we don't have any guides, so we have to align it by eye, as they say. We align it because if it's too high, the compressor won't sit flush, and if it's too low, the compressor's mounts could break. Be more careful with this cover. Well, here I also applied sealant using a tool and installed the oil seal. The covers are installed, everything is tightened, everything is good. Next I'll be installing the flywheel and the clutch. Before I start installing the flywheel and clutch, here's an interesting question. So in the first part of the video about this engine, there were some questions, a few questions and a few comments of this kind. What does the camshaft have to do with compression? Let me briefly explain, especially for our engine. The exhaust valve burned out, meaning the valve should move 15 mm and a certain amount of exhaust gases should pass through it. So this engine idles at 600 revolutions per minute, which means it makes 10 revolutions per second. Let me remind you that's still idle speed. 10 revolutions per second, that's what we get. There are 5 cycles, both intake and exhaust valves open 5 times each. In 1/10 of a second, a certain volume of hot exhaust gases must exit the cylinder. What happens if our valve used to open 15 millimeters, but now it only opens 7 millimeters? The opening's cross-section has been halved. The valve started to overheat because of these exhaust gases. The valve started to overheat and it simply burned through. Well, that's it. And once it burned through, naturally, what kind of compression will there be in the cylinder? That cylinder had no compression left. The camshaft was the cause here, and the burned valve was already the consequence. Also, if we keep discussing the camshaft, that's actually an interesting topic too. How does a worn intake cam lobe affect compression? There's a concept called volumetric efficiency. This value is equal to the mass of air that enters the cylinder in relation to its displacement. In modern engines, it can be up to 95% in modern engines. In sports engines, for example, it can even reach up to 120%. But in old two-valve engines, this value is usually around 85 to 90% or 82%. Well, it depends on the engine. We'll discuss this topic a bit more. So the displacement of this engine is 12 liters, which means the volume of one cylinder is about 2 liters. And we also have a coefficient. So the cylinder filling should be somewhere around that. Here we're considering the case with idle speed. So in 1/10 of a second, 1.8 liters of air should enter the cylinder. But since our cam is worn out and the valve was supposed to open, let's say 15/5/8 inch, but it actually opened only 7/5/16 of an inch. So that's half as much. So what happened? If the cross section, the opening through which we supply air, has decreased, but the time remains the same, I doubt the same amount of air will enter the cylinder. And it's difficult to determine how much air will actually get in. It's tough to say, but it's clearly under 1.8 liters and less than required. Now here's a question. Let's say the cylinder didn't get 1.8, but 1.5 or 1.4 liters of air. And now the question is, will 1.4 liters of air be compressed to the same degree as 1.8 liters of air? The compression ratio will be the same with a smaller amount of air entering the cylinder. Good question. I think the compression ratio will be lower, not the same. So, accordingly, our compression has decreased even though our valves are fine and the rings are fine. but because the valve opened less air came in. And as a result, we ended up with a lower compression ratio. That's an interesting point, yes. So these are just some small introductions and thoughts. Now I'm starting to install the flywheel on the clutch ease. So we continue the assembly ease. Next, I'll be installing the flywheel, the pressure plate, the disc, and the clutch. In general, assembling the flywheel, the pressure plate, and the disc. That they were recently replaced on this bus, so everything is in good condition and stays as is. I've washed and cleaned everything. The only thing is now I need to replace this pad. Here I have a new one. I've prepared the flywheel mounting bolts, the clutch cover bolts, and I'll be aligning it with the old primary shaft. So that's how it will go. This pad is simple to replace. Remove the ring, the pad falls out, then insert it from the other side and replace the ring. Here you can see these guides fit into special grooves on the tabs. That's it, the clutch basket is ready. Now I'm installing the flywheel. The flywheel is installed along the guide. The seals are acrylic rubber, the ones without a spring. We don't lubricate them with oil, they are installed dry. The flywheel is for me. This is the one I use. A lock. I insert the starter niche into the basket mounting hole. It's a bent Zavod Imeni Likachova rod. Actually quite convenient. That's it. The flywheel is tightened for me. Now I install the disc and the basket. That's it. The basket is completely tightened for me. Let's check. My input shaft moves in and out smoothly, so everything is centered. There shouldn't be any problems installing the gearbox, so next I install the fuel pump. Let me remind you, while I'm waiting for the piston rings, which I don't have, I can't insert the pistons or continue assembly. That is to seal the oil pan, cylinder heads, etc. I've installed the flywheel, clutch basket and disc with the flywheel in place. I can the fuel pump even without the cylinder heads. So now I need to bring the first cylinder to top dead center on the compression stroke to do this. I'll rotate the engine clockwise until the intake valve operates. We know that the intake valve is this cam right here. Basically, I can see it even without the pushrod and rocker arm when this valve operates. Next, I need to bring the piston to the top dead center, which I will also be able to see. Pin will just move as possible toward the cylinder liner, which means I'll have a top dead center P, and then I will need to set 15 degrees on the flywheel. In this inspection window, you can see the ignition mark, which is set between 14 and 16 degrees. We'll set it to 15 right in the middle. That later, if needed, we'll fine-tune it on the spot, plus or minus. So what we're interested in is the compression stroke. The compression stroke happens after the intake valve operates. You can check this cam by looking at it or pressing the valve, the cam. It passed the tappet, which means my intake valve has operated. Now I turn it until the crankshaft journal moves toward the cylinder. You can see the journal is as far toward the cylinder as possible. That means the piston is now at top dead center. Now I go to the inspection window and look. Right now, it's showing 0,1 just like this. I've set it to 15 degrees, so as we can see, here's the scale. Over there is 20, here it was 10, and we have 15 degrees according to this edge. That's it, my engine is set. Now let's check the pump. Here we have this inspection window. You can't unscrew this part because it's set up on the test stand. There's a plug like this, possibly for a hex key. Mine is a 24 mem connection, so we can see a little flag inside there. As I turn the pump and the gear, you can see that this flag moves back and forth. In theory, a factory lock should be inserted here. It locks this mark and sets it to the middle position through this hole. Well, basically you can just eyeball it. It's actually pretty easy to see right now. Right now, my mark is in the middle. If I move it like this, you can see that it's shifted. And if I move it the other way, you can also see that it's shifted. So we set it in the middle. And in this position, the pump should fit in place. If my mark has shifted, that means I don't have 15 degrees. After installation, if the mark moves, it means the engine is set to 15 degrees. But here the mark has shifted to the right or left. That means you can adjust it with these bolts. Just loosen them and set it. Turn it in the needed direction as much as necessary, or you can also adjust it with these bolts. But on this pump, there's very little movement on these bolts, so it's better to adjust it with the gear. Subtitles by Dimitar Zog. I installed the pump without the gasket, just put it in for now so I can see that my timing mark lines up, meaning it doesn't move anywhere. It also stays centered. Provided that my flywheel is set at 15 degrees before top dead center, we can all see that my timing mark is fine. I don't need precise adjustment, so now I can remove it, put on the gasket, apply sealant, and install it on the engine. Installed. So my next task is to prepare the pistons, which means I need to clean off all the carbon deposits, especially the deposits in the piston ring grooves and also in the combustion chamber on top. So for cleaning, I use old rings. I cut them on a grinder, sharpen them a bit, and just use this old ring to remove all the carbon deposits, well, like this. I clean the piston this way, and this is how it looks after cleaning. The key is to remove all carbon deposits from the grooves. So I've cleaned all the pistons. All the pistons are ready. I put in the old bearings since I replaced them during the last repair. They were already changed. The connecting rod has a groove bearing, while the cap has a plain bearing installed. So I received the piston rings. I'm opening them up. I'll measure them, definitely using a gauge to check the clearance. The ring breaks. When installing it into the gauge, it breaks. Well, it happens very rarely, but if there's some manufacturing defect, it breaks at that spot. That's why, to prevent this from happening, you definitely need to use a gauge when inserting it into the cylinder. Now I'm measuring the rings, installing them on each ring. There is a marking here, it says stop and the manufacturer's mark and the ring number. So these markings should face the piston crown. And like that on each ring you can see the top marking and the manufacturer's mark and the gap. I set the ring gaps at 120 degrees, meaning one ring, the second ring, the third ring, the third gap, all at 120 degrees apart. Alright, that's it. This piston is installed. We can see there's no play at all, the rings fit tightly, there's no excessive clearance. That's it, this piston is ready. I installed the rest the same way, all pistons are ready for ring installation. I've already installed the bearings. Now I'm wiping the crankshaft journals, wiping the cylinders, lubricating with oil and installing them. So in the end, I want to make a small announcement. I need a gearbox like this. This is a gearbox from a Setra 309 high-deck bus. It's like the Setra 315, just on a shorter base. So I need a gearbox like this, complete and in working condition. It broke the bearings, basically it chewed up all the teeth here. The drive and driven gears, meaning the main gear. There's no plate on the gearbox. There's this number cast on the housing. So basically you can identify this gearbox by this number. Here's what it looks like and its gear. It's the driven gear of the final drive. Here's the number, and here are the number of teeth, 13 to 42. So if anyone has something similar or knows where to get it, there are contacts in the channel description, phone number, WhatsApp, Viber, and email.